go.
Hey guys, welcome back to Kayla's Falls channel. Make sure to like and subscribe and leave a comment down below. Thank you.
Okay. All right, so we're going to be multiplying matrices. The back page of this is the hard part. It's kind of weird. So when we get there, I really need you to focus in and try not to skip ahead. All right, the front page is not that hard. First thing, scalar multiplication. A scalar is just a regular number. All right, so I'm saying I'm taking a regular number and I'm multiplying a matrix. And what you do there is you distribute the number to everything on the inside. So we're going to distribute the number to everything on the inside. All right. Negative 2 times 3 is what?
Negative 6.
Negative 2 times negative 7?
14.
Negative 2 times 2?
Negative 4.
And negative 2 times 4?
Negative 8.
And that's it. So easy.
Oh my god.
Number 2. When you have fractions, it's kind of like dividing. Remember, you do have calculators, just because we can't spend so much time on figuring out how fractions and negative signs work if you don't know. But 1/2 times 8 is
4.
1/2 times negative 10.
Negative 5.
1/2 times 2.
1.
1/2 times 4.
2.
Very good. All right, so those are the first two. Are we all good there?
Yeah.
Jump down to part B. Matrix equations. Slightly more difficult here. I want to solve for x. Now, I'm going to get rid of this 1/4 first because it's kind of like combining like terms. You know, you want to simplify it as much as I can before I start solving. So I'm going to take the 1/2. I'm going to distribute it to everything here on the inside. Or sorry, 1/4. 1/4. So negative 6 times 1/4. Negative 3 over 2. 2 times 1/4. 1/2 or 0.5. 8 times 1/4. 2. And negative 8 times 1/4.
Negative 2.
All right, now remember the goal here is to solve for x. So what do I do next? By what?
2.
By 2. Very good. Divide by 2. Divide by 2.
Same as multiplying by 1/2.
Which is the same as multiplying by 1/2.
2.
So negative 3/2 divided by 2. Uh-huh.
It's 3/4.
Yep. Negative 3/4. 1/2 divided by 2.
1/4.
1/4. 2 divided by 2.
1.
Negative 2 divided by 2.
Negative 1.
And x is by itself, so you're done.
Oh gee, that's just not x.
Okay, number 4. We're solving for z here. So I want to get rid of this matrix C right here. Is this matrix C positive or negative? Positive, because there's no negative sign out here in front. So it's an understood positive. How would you get rid of it? Subtract it. So we're going to subtract negative 4, negative 9, 12. And if you do it to one side, you have to do it to the other. One of the biggest mistakes that people make is this z right here. You're going to drop the z down, but you can't lose your negative sign because we have not done anything that has gotten rid of the negative, so it's still there. All right, all of these we're going to subtract them. So negative 12 minus negative 4.
Negative 8.
Negative 8. Negative 5 minus negative 9.
4.
And 7 minus 12. Very good. Okay, and I want to get z by itself still. So how do I get rid of the negative?
You
Divide by what?
Negative 1.
Divide by negative 1. Divide by negative 1. Negative sign goes away. So negative 8 divided by negative 1.
Just positive 1.
Positive 8.
Positive 8.
4 divided by negative 1.
Negative 4.
Negative 5 divided by negative 1.
5.
And Z is by itself now, so I'm done. All right, hopefully that part we got. Are you ready to do the back?
Yeah.
All right, I messed up a little bit on the back, my bad. It's not really that big of a deal. I want this to say rows has to equal columns. I went backwards. Are there two M's in columns? That's just, it just looks weird.
You spoke to right.
Okay. Columns. So rows have to equal the columns for this to be possible. All right, matrix multiplication. When you are multiplying two matrices together, it is different than what you would think. All right, you would think you just multiply the numbers, boom, you're done, because matrices are so easy. But it's not like that. All right, this is the only thing that is different. I made this nice little poster right here to remind you how matrix multiplication is. So we're going to be having a pattern here: row, column, row, column. All right, so that's why I wanted to say rows has to equal columns. For matrix multiplication to be possible, the numbers in the rows, the amount of them, has to have the same amount in the columns in the other matrices. So like here, how many numbers are in this row?
2.
How many numbers are in this column? 2. So those have to equal. That's what this means. Rows equals columns. So the number of numbers in the row has to equal the number of numbers in the column. Say it again. We'll get there, so just hang on. All right. There's a pattern to this multiplying. This thing right here, it's a pattern, and once I do it, it's going to make sense. All right, I'm going to draw a giant matrix here. I will tell you how to get the number in a second, but I want you to understand the pattern, because that's just going to help you so much when you are finding the answer. This is the first row, first column, right? So that's going to give me the number in the first row, first column. Does that make sense? So first row, first column will give me the answer of first row, first column. Okay. First row, second column will give me the number that's going in the first row, second column. Does that make sense? Okay. Second row, first column, second row, first column will give me the number in the second row, but the first column. Second row, first column will be in the second row, first column of your answer. And then second row, second column will be second row, second column of your answer.
Why do you use the second row 3 times?
I used it twice. Second row, first column, right here. Second row, second column, right here. So the columns and the rows, they should match up. So let me kind of go through it just one more time if you didn't get it. The pink one, that's the first row, first column. So in your answer, it's the first row, first column. Does that make sense? You see how this is in the first row and the first column? Okay. The blue one, first row, second column. So that's going to be the answer of the first row, second column. This one is the second row, first column. So that will be the second row, first column. And then the last one, second row, second column will be in the second row, second column. Does that make sense, the pattern? Do you see? When I say the words, it sounds very confusing because I'm saying second row, first column, second, like so many different times, but that's the pattern. Okay, now how to get these numbers. You can just set it on my desk. I'll fix it later. All right. You are going to multiply the two first numbers. And you're going to multiply the two second numbers and add them up. So to get this number here, we're going to do 0 times 8. And we are going to add it to 2 times negative 1. And that's why you have to have the same amount of numbers in the row and the column, because you're going to be multiplying the ones that are in the same spot. So 0 times 8, 2 times negative 1, and then you add them up. All right? Over here, we're going to do 0 times 3, and we're going to add it to 2 times 2. Okay, down here, this second row, first column. So negative 4 times 8. And then 5 times negative 1. All right, and then what two numbers am I going to multiply for this last one? Negative 4 times 3 plus 5 times 2. All right, so that's the hard part, setting it up. I put number 7 twice, so you can cross out that one if you have to like merge into that area. All right, so now I'm going to start multiplying. What's 0 times 8?
0.
What's 2 times negative 1?
Negative 2.
Okay. What's 0 times 3?
0.
And then 2 times 2?
4.
Okay. Negative 4 times 8? No, 32.
Okay.
And then what's 5 times negative 1? And then what's negative 4 times 3? And what's 5 times 2? Okay. Almost done. Add them up to get the final answer. Final answer, 0 plus negative 2. 0 plus 4. Negative 32 plus negative 5. And negative 12 plus 10. And that's my answer. All right. Now your test is going to be calculator. And there is a way that you can type this in to check it on the calculator. So let me show you how you do that. Okay. All right, I didn't, what's up? Yeah. I didn't show you this button yesterday because it didn't really help you, but there is a shortcut to getting a matrice, and it's this black button here next to the 9. All right, so this guy right here, not the book, the one right next to it. So if you click that, you have these matrices right here. Now it only gives you these sizes. So if you have a different size than this, you have to do the menu, matrix, create a matrix, and all of that stuff. But if you have one of these sizes, you could use this black button here next to the 9. So I have a 2x2. So I hit enter. And I'm going to put my numbers in. 0, 2, negative 4, 5. Press it again to put the other guy in. 8, 3, negative 1, 2. Hit enter, and your answer there should match your answer at the end. Make sense? It's understood. You could put a little multiplication if you want, but it's understood if you just put them.
So
Yeah.
you did all of that?
On your test, I need to see some work. Okay, I know some of it you can do in your head, but I need to see some kind of work that you know how to do this pattern. All right, but you can check yourself with the calculator. Does that make sense? All right, let's do another one. Go to number 6. All right, on number 6, I'm first going to highlight row and column, because that's where you're going to start. Row, column. Do you have the same amount of numbers in the rows and then that you do in the columns?
No.
No. So is it possible?
No.
No. So no solution, undefined.
Does it matter? When you put the first one, you put column and row. Does it matter?
Yes, it does. It has to be rows by columns.
If you column rows.
You can't. Row, column. Has to be row, column.
Is this also no solution?
Let's check.
Wait, oh no, never mind.
One row and one column.
Yeah.
All right, so I'm going to underline row, column. Do I have the same amount of numbers?
Yeah.
How many numbers do I have? So because you only have one number here, there's nothing you're going to be adding. All right, so all you have to do is multiply them. Does that make sense? So the difference between this one and the one I did up here, when you underline row and column, I have two things I'm going to be adding together here. Over here, row, column, I don't have anything I'm going to be adding because there's just one number in the row and the column.
Does it matter which way you put it, vertical or horizontal?
You have to go row, column.
Okay.
Oh, okay.
Oh, we have to do row. Isn't number 7 the same as number 8?
Yeah, that's why I crossed out number 7.
Oh, you cross it out.
Yeah, because my work went way over. I meant to delete it. I just forgot, I guess. Okay, so in this guy right here, what two numbers am I going to be multiplying together? 6 times negative 5. All right, what about in this guy? 6 and 4. Row, column, so this is 6 times 4. What about down here?
Negative 8 times negative 5.
Second row, first column, so negative 3 times negative 5. And then what about this guy right here? Negative 3 times 4. So to get your final answer, you just have to multiply all of these guys together. So what's 6 times negative 5? 6 times 4?
Why can't they just all be this simple?
15. Negative 12.
So yeah, some of them are more complicated than others.
Like that first